This lesson is on solving special case equations. So first, it's important to understand what a special case equation is. Up to this point, we have solved equations, and when we solved them, we came up with one answer. Anytime you come up with one answer, or sometimes as we continue through this, you will come up with more than one answer, that you can plug that value back into the equation to make the equation true. Those are all called conditional equations, because whether or not the equation is true is conditional based on what value you're plugging in. So if you plug in a 0, it's not true, but if you plug in a 2, it's true. So it's conditional. The two that we're going to focus on today are contradictions and identities. So a contradiction is when there's no value that we can plug in for our variable to make the equation true. So when we do that, when we solve, it's going to look like this at the end of our equation. You're going to come up with some sort of two constant values that equal each other that don't actually equal each other. So obviously 3 does not equal 0. When you have a contradiction, that means there's no solution. So we call it a contradiction, and if they ask for the solution set, we would say that's the empty set. For identities, that is very similar, where we're going to get to the end of the equation, all of the variables are going to cancel out and go away, but what you're left with will always be true. So in this case, 3 equals 3. So it's a true statement, and a true statement means that it's an identity, which means we could plug in any value that we wanted into the equation, and the equation would still be true. So if they ask for the solution set of an identity, that would be all real numbers. So we use the R to denote all real numbers, but it's basically any value that we want we can plug in there and it would work just fine. So let's take a look at what that's going to look like in an equation. For our first one here, and again, I gave us some tough ones so we could do some more practice. I'm sure you appreciate that. For our first one, I'm going to go ahead and distribute the 5 to the d and to the -2. And on the right side, I'm going to go ahead and combine these like terms. So 12d and -7d is 5d. And now, before I add or subtract anything to both sides of the equation, I'm going to combine like terms on the left side. So these two on the left side, -1 and -10, combine together to give me -11. Nothing else happens on the right side. Now I'm going to subtract 5d from each side because I want to get rid of the d's on one side of the equation. But notice what happens. 5d minus 5d cancels out and I get -11. And 5d minus 5d cancels out and I get +3. So -11 equals 3 is clearly not a true statement. This is called a contradiction. A contradiction because there's no value I could plug in for d to make the equation true. The solution set for this would be the empty set, which means there's no values that work. For our next sample here together, again, I'm going to distribute first to get 7k plus 28, and the rest of the left side I'll just recopy. On the right side, I'm going to go ahead and combine 3k and 4k. And I'm going to combine 20 and -2 to get 18. Now I'm going to combine like terms on the left side. So 7k plus 18 equals 7k plus 18. So right away I can see that I have the exact same thing on both sides. But let's go ahead and subtract that 7k just in case this is where you end up. I would end up with 18 equals 18. This equation is clearly true, which means this is an identity. So it's an identity. The solution set would be all real numbers. Depending on how they ask you to write it, it could be the set of all numbers x such that x is a member of the set of real numbers. So just pay attention to what the instructions say if you get questions like that. Let's try these last few. 2 times x is 2x, and times -3 is -6. On the right side, I'm going to combine like terms. So right away I can see I've got 2x and 2x on each side. When I get rid of those two x's, I'm left with -6 equals 17. There are no x's left, and this is not a true statement. So this one is a contradiction, and my solution set is no solution for the empty set. By the way, the empty set is also shown like this sometimes. So again, just pay attention to what they're asking you for. And for my final question here, I've got 5x on the left. On the right, 3x minus 2x is 1x, and then keep the -12. I'm going to subtract the x from each side. And again, when you just have an x with no coefficient, the coefficient is 1, so it's okay to write it in there if you'd like. 5x minus 1x is 4x. On this side I get negative 12. And when I divide by 4, I get negative 3. So in terms of the question that was asked at the beginning, this is a conditional equation, and the solution set is negative 3.